Now we're going to have some fun. I am going to go through the process for repairing bad blocks, or at least reconstructing partial blocks or mystery blocks out of bad blocks. And this is about the worst that I've seen because I just don't understand it, so I thought it would be an absolutely fantastic example. This tape that's part of my project here is hand-labeled Kennedy Backup Disk Utility with this date here. And I've read the entire tape using my Universal QIC cartridge reader, which you can find on other YouTube videos. And I've even done some manual track adjustment just to make sure I'm not missing anything. And all I find is the semblance of 3 blocks on track 0. Let's look at those. We're going to open the Saley Logic Analyzer here, and this is the logic capture file for this particular read. Now, I've adjusted the resolution. I only needed to read just a few seconds. Looks like I read about 6 or 7 seconds here. But I could see fairly easily that there was only 3 blocks of data, or what looks like 3 blocks of data. Now, this is the enigmatic Kennedy format. I've written about that over here. Written about that here rather extensively to talk about exactly what's going on with the format there. One of the unique things that this format has is interblock data, interblock spacing. I think interblock gaps. That's right. It has interblock gaps of a certain period of time. So unlike QIC 24 and QIC 11, where the track is a continual stream of data from start to finish, where blocks are separated by a combined preamble postamble, these actually have blocks, have gaps between the blocks, and evidently those gaps are supposed to be very specific. It says a distance of something like that. Sorry, I had to correct a typo on my own page. It shall be a minimum of 1.2 inches. Well, I don't measure in distance in this. I measure in time. But we'll get to that, maybe later. That's not actually what this particular demonstration is about. But if you want to read about the interblock gaps, you can simply go to this page on my website about the enigmatic Kennedy 6450 tape drive format and go to the interblock gaps section. Anyway, that makes it very easy to see visually where the blocks begin and end on the logic capture if you change the zoom correctly. Now, I'm using the scroll wheel on my mouse to zoom, and I'm going to start at the beginning of the capture. Now, the beginning of the capture should be entirely noise. This is noise. I don't understand why exactly. I do, but I have determined that the hardware itself, whether the tape is moving or not, when it's in a position to read the tape, the hardware is producing static of some kind, like this. And this is just static. There's no pattern here whatsoever. There's no structured data. Looked at this a lot. Initially, I thought there might be, but there isn't. And I was, learned how to rule it out quickly when I wasn't moving the tape and I was still capturing these things. All right, so let's move on. This is just noise. I like to adjust the resolution to be about here so the noise is obvious. Much smaller than this, well, it's not so obvious. Here, a nice mix of white and black lines here. Just kind of a visual aid. Now, what I'm going to do is scroll through here, and at some point this will turn entirely white. That's where the structured data begins, because the gaps between all of them are much closer, and so that's why you won't see the black lines anymore. So we scroll to the right, and there. Whoa, went too fast, and there it is. See how There's structured data there. Okay. And the line where structured data starts is right here. Now, when I determine a format on the tape, I take these captures and I go through this process and I look at the beginning of it. And if it's the beginning that I recognize, then great. I can tell whether it's QIC 24, QIC 11, this enigmatic Kennedy 6450 format, or some other format that I have not yet properly identified and documented. But I can see what it is. So, from the beginning here, I should be able to tell what this is. And I zoom in, and here's the problem. The first thing I expect to see with the data block is a preamble. A preamble is even spacing like this of, at least with the Kennedy, it's technically supposed to be exactly 80 magnetic flux transitions in a row. So let me show you what one of these is supposed to look like. I have an example. Alright, I pulled up what should be a fairly good track read that lasts all of almost 90 seconds. So I went through an entire track here. And this is the Kennedy format. So I'm staying at the beginning, and I'm going to zoom in on this noise, and I can see. All right, these still aren't close enough, believe it or not. So maybe the example wasn't absolutely fantastic. There we go. Okay. That's what a preamble is supposed to look like. Now the Kennedy format has this really has some really bizarre stuff going on, like these things. We'll get to that later. I don't think this is GCR 4.5 like the other formats that I'm dealing with. I think this is a result of the pre-formatted tape. We're going a little bit too deep here. All I wanted to do was show you the beginning of a preamble. So let's have a look. So here it is. I can see fairly easily, using my scroll method, ignoring that. This, I think, again, is part of this format for the pre-formatted tape. This is so difficult to scroll through. This is the resolution that I want. Here we go. So that ends there. We scroll through lots of blank, and now we're going to come upon this weird thing, which is some kind of marker, but the preamble. And I've been successfully reading these tapes, identifying a block as this. Okay, so here we have a preamble. It's not a preamble. I'm going to have to edit this section out. This is something else that I also ignored on here. Maybe I won't edit it out. Every once in a while you see these things. Fascinating. There we go. There's the structured data I was looking for. Yes, much better. Okay, so the beginning of a block, this Kennedy 6450 format, should look like this. That's a preamble, where the noise subsides, and all of a sudden you see this block of data. And the first 80 transitions are uniform. That is the preamble. I think that's supposed to set the phase lock loop clock. Then the first thing that we see here is the sync character, or the sync byte, sync bit, sync nibble, which is essentially a 00111. And then we start with the GCR 4.5, 1111, 0111, 0111. All right. You can read my page as my page is about this format if you'd like to see my documentation on how I've identified the individual nibbles in here. But Suffice it to say, if I'm dealing with Kennedy 6450 format, I expect to see a preamble and a postamble. Let's look at the postamble. We're just going to scroll through here. Yeah, did you see that? So these are these inner block gaps. And now I'm just scrolling through here. I'm scrolling through the blocks of data where you can see the gaps. This is where the first block of data starts. No, it isn't. I keep lying to you. I picked a really interesting one, didn't I? There. That's where the first block of data starts. But you can see, once I get to this resolution, this one's longer than the rest. Then there's this. Then there's this. We zoom down. We zoom out, I guess I should say. You can see it more clearly. There's the data blocks. So we'll pick one here. We see the preamble. Excellent. So now we'll go over here. And this is where I was really confused. Because on this tape, we scroll through the noise. We find one block, two block, three blocks. But these blocks are incredibly unusual. And here's why. I can tell they don't have a preamble. They have nothing. So they go right from noise right to structured data, which really confuses me. From noise right to structured data. See, this is the end of the noise. This is the beginning of the structured data. 1, 1, 1, 1, 1, 0, 1, 1, 1. And all of these, you see a gap is 0. This gap is twice as wide, so it's 2 zeros. And you never see a gap wider than that in the GCR45 encoding format. But I say to myself, well, I can't imagine something without a preamble, but let's check it out anyway. Let's go to the end and see what the end looks like. All right. So here is the end of the structured data. And lo and behold, I see a postamble. Now, we could say that, gee, I just read the tape backwards, and this is really the preamble, but then there should have been a postamble on the other end. All of these, the Kennedy format has this. So I did a lot of analysis and wrote some programs, and I've at least decoded what we have, and I'm piecing it together, trying to make sense out of it. I'd like to demonstrate that process. So I've written programs that I call block repair. I have a block repair setup program, which does all kinds of cool things. Basically, what it does is I manually mark a place in my master decode log where I want it to start. And the program assumes that there's going to be a postamble, so that's good. Usually the block errors or false starts or something wrong with the preamble, or the block is interrupted, and so I have to start over again, in the middle of the block and try to read the rest of it. So I'm going to demonstrate that here. I've already pieced together the first two blocks, and they look really weird. And you're going to watch my experience here live on the third. Okay, we'll close this. So that's from the previous ones. So this is not the one that I want. This is the one that I want. The Kennedy Backup Disk Utility Track 0F. Okay, so in order to identify the blocks, I basically zoom to about this level, and then it's very obvious where the block ends and begins. So as I scroll through here, let's see how many blocks there are. 1. Alright, so let's see. That's 1. There was the block marker there. Excuse me, the whatever's in between, the noise in between. 2. I had this up really nice. So we have 1, 2, 3. And is that it? I think it is it. That was it. 3, 2, 1, 2, 3. So what I want to do is to find the beginning of the third block, which I believe I've done here. Now, once again, all of a sudden it just jumps in here with structured data and no preamble. This is just the noise. So, I cannot explain how this happened consistently on 3 blocks. One I can explain because that section, may have just gotten erased externally somehow. But this part is just weird, so I have no explanation of it. But let's at least see what is there. Once we start structured data, let's see if we can read it. Now, the hardest thing here is to know where things begin. If you look up bitwise shifts, you can see what happens if you miss a data pulse, or if extra data pulse is inserted. The shift of all of the bits are off, and so where one nibble ends and the next nibble begins, that location is not clearly known. So what I've done is I've written a program that basically looks at the set and shifts 5 each direction, because GCR45 is 5 different values make up a nibble. So when I shift it 5 ways, one section of this data should become somewhat readable, somewhat obvious. And so let's look at how my programs do that. Alright, so here's how I'm going to proceed. I'm going to find the general area here by time where I want this to start. So I want it to start, let's say, right here. Alright, so visually I've located a location. Now in order to go back to my master log files, I want to find a timestamp. So I zoom in here up until I get as close to a timestamp as I need, as I want. So it looks like the closest item is going to be 1980. Now let me write this down here in front of me so that I get this. 1980322. Now I happen to know that this is 1.9 seconds in. We can see that when we zoom way out here. So that you can't tell that it's not on 2, it's actually just before the 2. So that's where we are, 1.9 seconds in. Now, what I've done is I've taken this exact timestamp, and I'm going to search for this unique value in my master log here. What is it that I call it? I have to think about my own naming convention. It's not that one. It's the master decode log. This one right here. This is the most granular information that my program spit out that shows how the first step identifies everything. It goes through the entire dump file. the entire export from this. The export that I do by going to export data, only export channel 0, which I've labeled 26 read pulse data, and export that to CSV. So let's open this up, master decode log here. And it's a very large file. It's something like 60 megabytes. And there's not just one. I've split it up into various blocks so that this thing doesn't become unreasonably huge. I'd still like to be able to open it in Notepad with definitely having word wrap off and being able to hunt through things in here. So my programs are designed to split these up for every 20 blocks, I believe. Yeah, that's it, every 20 blocks. But the first one is always longest because it has all of the noise before the first preamble. This one, it never found a preamble at all, so it never identified a single block, but all of the pulse transitions are as picked up by the magnetic read head, even the noise, are still in here. Point is, I'm going to search for this value, because every single line here is timestamped. And it found something. What did it find? It found that exact item. The X's are gaps that are too wide. The 1s are gaps that are wide enough to be a 1. The 10s are gaps that are wide enough to be a 1-0. And the 100s are gaps that are wide enough to be a 1-0-0. My programs just concatenate these things as it steps through. But since it did not identify a preamble, I go through this process and I identify the start point myself. So basically I want it to start after this line. So I'm going to copy this line right here. And I'm going to open up my program source file. So this is already set to the name that I want. This is the file that my programs read to say, which files do you want me to open and work on? And because I run multiple programs in succession, instead of me specifying that inside of each program, I just have another external file here where I specify this, and all the programs open this file, step through it, and read it. So this is all the same. I haven't changed this. This is the same here. Source file, file path. MDL block end. This basically is the end of the master decode log. Is this block number 1? Is this block number 21 and on? Is this block number 41 and on? And so on and so forth. Well, this is block number 1 and on. And it never found block 1, so that's all the further we ever got. But I need to specify this so that it knows which master decode log to open. And then the bad block start marker. Now you notice there's no quotes here. That's because my program knows exactly where to open this file, because I have these field names here. It starts reading right here, right here, right here, all the way to the end of the line. So I've designed it to do that. Not to be confused, that's why there's no quotes. Let's paste this in. Now I have that value there. Good. And this is going to be block 3. This is going to be the bad block start marker name. I know that's really descriptive, which is why I'm really not releasing these programs to anyone. This is all just internal development for me, but I'm certainly sharing the methods that I use in case it gives anyone ideas to adjust my programs or write their own. So this is what I'm naming the series of export files on this so that I can see what the results are. I'm going to change this to block 3, and I want to specify the time that the block ends, because all the way through I identify the time of a block by its end point, not by its beginning point. So more on why later. It just made more sense at the time when I was writing my programs. So I'm going to search for another. I'm going to search for another process where it identifies a preamble postamble, and it can't tell the difference between a preamble postamble because basically, 10 consecutive. It ends up being like 10 or 20 consecutive or 80 consecutive ones in a row. In this case, means a preamble or postamble, and it can be either. So let's look for the word preamble colon. That's what I wrote my programs to write when it finds a period of repetitious ones. Okay, and there it is. So after it finds 70 or so ones in a row, it changes the line status from not a preamble to preamble short, and that's what I was searching on, because my programs do that. And in essence, my programs correctly identified this, and once the preamble postamble ended, it set some parameters based on the averages that it took from this for timing data, phase lock loop timing data, to identify the timing of those other items, the ones, the zero, the ones, the 1 0, and the 1 0 0s that you saw above. Anyway, the whole thing that I want to say here is this is the timestamp that I want to use. 2.172209.125. This is the end of the block. At least it's clearly defined, the end. So I'm going to plug that in right here, and that's just for my own use. Now, go through the X's. There are going to be other errors in here that are not identifiable characters, I'm sure, between my start point and my end point. That's okay. I wanted to create an additional file that reads through them. So let's see how this works. Save the file. I can close it. That's fine. Now I'm going to run my master run block repair Kennedy format, which runs several other programs in succession. And actions run. And here we go. Oh, I have the debugger on. I don't want the debugger on. It takes too long. Tools, debug loader script, take that off. Actions run. And we wait a few minutes until we see a finished status pop up here. Meanwhile, I can go over here, sort by date modified, and click refresh a few times. And I can see this thing populate over periods of time. Okay, and I think it's done. Yes, it is. Now this has created 3 files of relevance. This 4th file was something I was testing with, and I never took it out, so forgive me for that confusion. The first file that it creates is just a capture, a concatenation of the 1s and 0s between my start point, way up here, and the preamble colon. So my start point, which was up here somewhere. So this is it, the 1s and 0s. Now, I think there's going to be some X's in here, which means it couldn't, the gap was too wide for it to be identified as a 1, a 1 0, or a 1 0 0. Now, again, I'm always doing this with word wrap off, and even though this is just one line, Notepad does wrap at 1024 characters, so that's why you still see multiple lines here with a single line of text with word wrap off. I'm going to search for an X, which is my identification of an unidentified character, and amazingly, it doesn't find a single X. I was not expecting that. Okay, good. So this program now shows me different shift points, 5 to be exact, and it basically starts by taking the whole thing, shifting it 5 ways, and then analyzing what you see in there. So this turns out to be a very valuable tool for me. I have some parameters here at the start. Very good. So again, it throws in all the 0s and the 1s here. And start point number 1. Well, these X's would be a GCR pattern of 5 characters. that it could not identify as a hexadecimal character or as a preamble, sync, or file mark. And so we see a bunch of X's here. And so my program basically looks through this and says, is it an option? No. Why? Because X nibbles are found, meaning that unidentified nibbles. Here's start point 2. Well, this looks a lot better. Is the option possible? Yes, it's possible. Why? Well, because it identified the whole thing and thought that it was just fine. This is an end mark, which is basically one string of 5 data pulses. That's that enigmatic Kennedy thing. And so that's P for a single preamble, postamble character, but it also uses it for an end mark. This is the marker that Kennedy uses between the end of the data block and the beginning of the CRC. And it does not have a parameter for block ordering, for block numbering, like QIC 11 and QIC 24 does. So figuring out which block in the sequence it is supposed to be is very much a guessing game, much like all of this is. But yet there's a science to it, and we're going through that science. Okay, so really, this should be the whole block, minus the preamble, of everything that's readable in this third block. So let's have a look at what that is. I'm going to copy this and open my hex editor and create a new file, and I'm going to paste this in there and see what we get. And it didn't object to anything. It did not object to anything, which is fascinating. Meaning that there wasn't a P for a preamble in here somewhere, or an S for a sync character, which is the beginning, the way I denote the beginning marker, the beginning of a block marker, or an M for a file mark, which is a unique GCR5 code, GCR45 code of 5. You'll find that documented on my QIC 11, QIC 24 page. Regardless, let's have a look at this. So we definitely have some structured data here, and wow, look at this. We have a 0.4 disk system subutility, version 1.4. We've got some stuff here, man. This is cool. So it seems like most of what probably is an executable program by the 0.4 system. Fantastic. And I'll bet I could find a copy of this somewhere in the other tapes that I've restored. But let's have a look at this block. This is just completely crazy, and I don't think I understand it. But let me even this out. Even if everything was 8 bytes, even if a block was even an increment of 8 bytes. Before this moment, I've never seen a block that's any other size other than the following 3. 512 bytes, 4096 bytes, or 8192 bytes. QIC 11 and QIC 24 both use strictly 512 byte blocks, no longer, no shorter. What makes this so hard is, obviously, I found, if you look at my page on the Kennedy format, that the block sizes vary. And I have a whole section on this. Data block format, CRC, file marks. Here in the data block format, I think I talk about the sizes. Yes, most important part is the data segment. The data segments are much longer. So far I found 4096 or 8192 bytes. This is the first instance of anything that's potentially longer. So I'm finding it right now for the first time. So how long is it? Well, I must be missing something, because I cannot imagine that there would be an uneven grouping of 8 here. So at the most, we have some characters we need to add at the beginning, And so I like to do that by adding this character here, the pipe. Uh-oh. Edit, undo. And I think, what did I want to add at the end to make it even out? 1, 2, 3, 4, 5 bytes. So let's just have five of these. There we go. So let's insert that at the beginning and see if we can even this out. Because at this point, if there's anything missing, it's at the beginning, not at the end. Because the end shows a file mark and a CRC. Not a file mark, but an end mark and a CRC. So now I'm looking at something that potentially could be 13,488 bytes. That's a very odd length. Odd is an unusual, strange. I mean, all the others were divisible by 512. So this is difficult to explain. Why it would be 13,480. But it is. Or longer. It's at this data block is at least 13,400 excuse me. It's at least 13,488 bytes long. Never seen that before. But that is it. So I'm going to change this back to a more pleasant view, which is 32, even though I'm sure that this machine would never operate with this long of a word size. I like to display that because it shows more data, more text on my screen, and I don't have all that wasted space on my screen like I do here, all this wasted white space. So that's personal preference. But now we have something here that I think is worth analyzing, and that is how I use my programs to identify and repair bad blocks. This one worked extremely well. I'm going to go through one where I actually had to piece it together, where I had a beginning and an end, and then missing some pieces in the middle, and then it was just guesswork as to how much was missing in the middle. But let's move to that next. Hopefully this wasn't too boring. On to the next.